Welcome guys. So today we solve 31. Which of the following cannot be a root of polynomial in x of the form 9x4 plus ax cubed plus b, where a, b are integers. Okay, so the key theorem is the Newton's theorem. Basically, suppose you have polynomial in integer coefficient. Basically, f is the form of a n x n to a1x plus a0 when the f is non-zero. If x equals to p over q is a root of f, then q divides an and p divides a0. This p over q is the need to satisfy additional conditions that p and q should cooperate. And I will not prove this theorem here, but hand waving is like you can write f into qx minus p and something. So intuitively, this an should be, this q should divide an and p should divide a0. And to prove it rigorous, you need to plug this into this and do the expansion. Okay, but I think it's trivial that you can prove it by yourself. Okay, so once we know this, that we know that C is not the answer, because 4 need to divide 9, right? Because 1 and 4 are coprime, and the 4 need to divide 9, and which is impossible to 4 divides 9, because 9 is not multiple of 4. So the answer is D. The answer is D. That's it.